The James Webb Space Telescope has unlocked a cosmic secret, unveiling a discovery that could rewrite everything we thought we knew about the early universe. For decades, scientists believed that the dark ages of the universe began shortly after the Big Bang and lasted for about 1 billion years. But did it really? At this time, the universe was thought to be shrouded in dense clouds of neutral hydrogen gas, which blocked all light and made observing the formation of early galaxies nearly impossible. However, recent observations from the James Webb Space Telescope suggest that our understanding of this crucial epoch might have been incomplete. The James Webb Space Telescope has detected mysterious light sources from the so-called Dark Ages, raising serious questions about our previous theories. This revolutionary telescope is now shedding light on a period previously considered beyond the reach of direct observation, offering clues that might rewrite the narrative of how the universe evolved. According to the Standard Model, the early universe was filled with dense neutral hydrogen, blocking out light until stars and galaxies formed. Scientists believed only then could light escape through ionized hydrogen bubbles. But the JWST has observed Lyman Alpha emissions from early galaxies, revealing that light pierced through these hydrogen clouds much earlier than expected. This discovery challenges the idea that the early universe was entirely opaque, suggesting that ionized channels and bubbles formed sooner, allowing light to escape earlier in cosmic history than we previously believed. Even before the launch of the JWST, researchers had detected faint Lyman Alpha emissions. Still, Webb's superior capabilities have confirmed that light was present during what we once considered the darkest period of the universe. These observations suggest that stars and galaxies formed much earlier and on a much larger scale than we previously thought. Since its launch in 2022, the JWST has shown us a series of galaxies that were already quite advanced and luminous during the Dark Ages. The fact that we can see these galaxies means that the universe was permeable to light much earlier than we anticipated. What's more, these galaxies are larger and have higher rates of star formation than previously thought. This challenges the long-held idea that the early universe was a slow, gradual process of galaxy formation. Instead, it suggests that the early universe may have been bustling with activity, filled with bright star-forming galaxies. These revelations paint a very different picture of the universe's early years, one where light was abundant even during the supposed Dark Ages. Perhaps one of the most significant discoveries made by the JWST is the detection of two extremely old galaxies that existed long before the Dark Ages were thought to have ended. The age of these galaxies is so extreme that they might have formed before the Big Bang itself, which poses a serious problem for our current cosmological models. These galaxies exhibit a range of properties that don't align with the established models of the universe's origin. One of the most startling discoveries is the presence of a supermassive black hole at the center of one of these galaxies, just 400 million years after the Big Bang. Current theories suggest that supermassive black holes form over billions of years, either through the collapse of massive stars or the merging of smaller black holes. The existence of such a massive black hole so early in the universe's history turns this theory on its head. The presence of light, particularly Lyman Alpha emissions, during this era raises profound questions. Lyman Alpha emissions result from the transition of electrons within hydrogen atoms, typically found in the UV spectrum. Due to the expansion of the universe, these emissions are redshifted, making them easier for the JWST to detect. This means the JWST is perfectly suited to capture and analyze these emissions, which are acting as beacons from the early universe. Lyman Alpha emissions play a critical role in helping astronomers understand the processes that took place just a few 100 million years after the Big Bang. This is the period when the first structures in the universe were forming. But as new evidence rolls in, there's increasing uncertainty about whether the Dark Ages and the process of reionization, the point at which the universe became transparent to light, ever really occurred as we imagined. Until now, scientists believed that after the Big Bang, the universe experienced a period of darkness, followed by the birth of stars and galaxies that gradually lit up the cosmos. But if the Dark Ages never existed, or at least not in the way we thought, then it means that our understanding of the universe's evolution is fundamentally flawed. Thanks to the JWST, we are now gaining more insight into what was really happening in these early galaxies. Lyman Alpha emissions give us clues about how many new stars were forming and how the intergalactic medium behaved. By studying these emissions, scientists can better quantify the rate of star formation and draw conclusions about the early evolution of galaxies. The JWST has already revealed an astonishing number of Lyman Alpha emitting galaxies, which have become crucial for understanding early star formation. For example, the galaxy GNZ11, originally identified by the Hubble Space Telescope, was once thought to be an outlier. Its existence, just 400 million years after the Big Bang, was seen as an anomaly. However, the JWST has confirmed that it is indeed real, and its Lyman Alpha emissions point to a galaxy undergoing rapid star formation. Another example is the galaxy MACS 0647JD, which is extremely faint, but also shows strong Lyman Alpha emissions, indicating significant star formation activity. These discoveries suggest that early galaxies were far more active than we had imagined. The JWST has also identified a galaxy known as EGS 8P7, which lies about 13.2 billion light-years away. This galaxy's strong Lyman Alpha emissions indicate that it was able to create bubbles of ionized hydrogen, allowing light to escape much earlier than expected. In addition to these revelations about early galaxies, the JWST has made a puzzling discovery about black holes. The supermassive black hole at the center of GNZ11 is far too massive to have formed through the processes we currently understand. This discovery raises new questions about how black holes form and evolve in the universe. Some scientists speculate that these black holes might have grown rapidly through direct accretion of gas, or that exotic forms of matter or energy could have played a role in their formation. As the JWST continues to reveal hidden details, and with new instruments like the Vera Rubin Observatory on the horizon, scientists are eager to determine whether these galaxies represent the universe's first structures, or if they belong to a far more ancient and evolved cosmic landscape. Time and further exploration will provide the answers. Feel free to share your opinion in the comments. Don't forget to like, share, and subscribe to Space Episodes for more exciting content.